Hey physics students, today we will be talking about the types of forces out there. We'll also be talking about contact forces versus action and distance forces. And we'll also be talking about the units of force and whether force is a scalar or a vector. Last video we talked about balanced versus unbalanced forces. We described what happens when forces are balanced or unbalanced. And then we're just going to dig into a little bit about the different types of forces. So an applied force is going to be a force exerted from one object to another object. And so here is my wonderful Expo marker. This is my hand, which is an object. This is another object. I exert a force on it, whack it, and it goes flying. That is an applied force. An applied force is basically anything touching this little beaker here. This cart would have an applied force, and now it's pushing that along. Gravity force, so force that massive objects exert on other objects. So examples, the Earth exerts a gravitational force on us. And all the things on Earth to keep them on Earth. The sun exerts a force on planet Earth, causing it to orbit the sun. And the Earth exerts a gravitational force on the moon, causing the moon to orbit the Earth. And then lots of gravity in space, but really gravity force is exerted by really massive objects. These two papers exert a gravitational attraction towards each other. However, because these objects are so small and not very massive, there's really not that much force. Normal force is what I like to refer to as the support force. So normal force is the force that the floor exerts on me. So supports me. Let's say I take a seat on top of this desk. The desk is supporting me and exerting a normal force upwards to keep me right here. However, normal force could be pointing other directions other than up. So let's take for a minute, I lose my balance and I need to put my hand against the board. Well, I'm pushing this way. Well, what's the board doing? The board is pushing that way and supporting me from falling through the wall. Same thing if I pushed up on the ceiling would technically be supporting me and pushing down. Yeah. Frictional force. Most of you should know about friction. Rub your hands together. What happens when you rub your hands together? Well, if you said they warm up, you're absolutely correct. That warming comes from the frictional force, and basically frictional force isn't that well understood, but basically there's these little micro cracks and micro divots in surfaces, and those little inconsistencies drag on each other. The smoother a surface is, the less friction there is. The rougher a surface is, or sticky the surface is, the more friction that is present. All right. Let's move on to air resistance. So air resistance is kind of like a frictional force, but it's air friction. Say you're driving down the highway, and how many of you stuck your hand out the window while driving? Maybe go down and up, and your hand goes like this. And you feel the force of air pushing hard against your hand. Well, that is air resistance. If you all of a sudden took the foot off of the accelerator in the car would start to slow down. That's due to both frictional force and it's due to air resistance. Air resistance, there's a pretty complicated formula for it. It actually depends on the speed of the object, depends on the surface area of the object, it depends on the shape of the object. A lot of scientists research frictional force or air resistance because developing airplanes, spaceships like that, it's very important to understand this force and how it reacts. Tension, this is a force through a string or rope. I don't have a string or rope right here, right now, but if I did, basically if I'm pulling a sled along on a surface, that string transmits the force from my hand to that sled. So anytime a string or rope is involved, we'll have a tension force. And then we also have spring force. All right, so I have a handy dandy pack of springs right here. So we got this spring, and I'm going to stretch it. What does this spring want to do? Well, it is stretched and it wants to go back to normal. Ow. So the spring force, if I pull down, the spring is pulling back up on my hand because the spring wants to return to its normal shape. That's called a restoring force. We could just call it a spring force in this case. Yeah. Alright, so those are the basic types of forces. There are a few other ones that we will not talk about very much, and I'll talk about them when we move on to this next piece. So, remember, a force is a push or pull as a result of an interaction between two objects. So, when I touch this cart, the cart speeds up. Once I let go of the cart, my hand is not interacting with the cart. The force from my hand and the cart go away. It's not present anymore. So the force only acts for as long as the two objects are interacting. All right. When the interaction ends, so does the force. This is a common misconception amongst physics students, but as soon as a force ends, the contact ends, the force stops. There are two different types of forces. We have contact forces and we also have action at a distance forces. Contact forces are when objects interacting are perceived to be touching. So I'm touching this object, that's a contact force. A string pulling an object, that would be a contact force. This spring attached to this cart, if I were to pull it by here, the cart would move because of the spring force that I would be exerting. Alright, frictional force is a contact force. Air resistance is a contact force because the air molecules are contacting the object and slowing it down. So let me write this down. Contact forces are forces such as spring, applied, tension, normal, air resistance, all right. Well, how about gravity? Is gravity a contact force? It actually is not. Gravity is an action at a distance force, and if we think about it, the Earth and the Sun are not touching, right? Thankfully, because we'd all be burned up to a crisp in the sun. So the gravitational force that the Sun exerts on the Earth, it acts at a very far distance, 93 million miles, about there to be exact. And so they're not in contact, but still able to exert a push or a pull. So these are forces like gravity, magnets, electrical. These are some examples of action at a distance forces. All right. So we've talked about the types of forces. We've talked about contact forces versus action at distance forces. And now I want to briefly touch on the units of force. So the units of force are newtons, named after one of our dead white dudes, Sir Isaac Newton. So units of force, the Newton. And 1 Newton is 1 kilogram meter per second squared. So it's units of mass along with units of acceleration. And we'll talk about why that is in another lesson when we get there. Now, is force, I want you all to pause the video and guess whether force is a vector or a scalar. So is force a vector or a scalar? Guess for me. All right. If you said vector, you are correct. Force is a vector. And the reason being is that direction definitely matters, right? If here, let's grab physics pony. If I have physics pony and I apply a force that way, well, that happens, right? However, if I take physics pony and apply a force that way, whoops, physics pony goes flying the other way, right? And so the direction of the force that's applied to any object definitely matters, because if we apply a different direction of force, something completely different is going to happen. I mean, same sort of movement, but the movement is in a completely different direction. So, force is a vector. All right. Hopefully in this video you all have learned the different types of forces, how to tell if they're an action at a distance force or a contact force, as well as learn the units of force and that forces are a vector as well. Thank you all for watching today. Have a wonderful rest of your day.